In this video, we'll introduce and use our three power reducing formulas. These are used, I don't use them very often, honestly. You use them every once in a while when you want to reduce the power. I think you'll use this a lot in Calc 2 when you're trying to integrate higher degree trigonometric functions, and it would just be easier if there was a lesser degree. For some reason, my students, this is like their go-to. This should not be your go-to. If you see sine squared, your first instinct should be Pythagorean identity, not power reducing formula. You'll notice that these power reducing formulas create a more complicated argument. It turns theta into 2 theta, and that's not usually very helpful for us when we're doing algebra. So we need these, they have their purpose, but this is not your go-to every time you see sine squared or cosine squared. And for me, I'm going to have directions like rewrite it. Rewrite is an equivalent expression that does not contain powers of trigonometric functions greater than 1. So we're going to use our power reducing formulas to end up with just cosine to the first. Well, you'll notice that our power reducing formulas, it's cosine squared, not cosine to the fourth. So the first thing you want to do is think about cosine to the fourth differently. This is the same as 10 times cosine squared squared. And now we'll use the power reducing formula for this inside portion. Everything on the outside is going to stay the same. So this will be 10 times 1 plus cosine of 2x over 2. And now all that squared. We want to simplify this because we still have the exponent of 2. And we have a binomial on the inside with that 1 plus cosine of 2x. So we're going to have to write that twice and multiply it out. Our 10's still hanging out in front. And that's 10 over 1. So if we're looking at all these fractions, that 10's going to be in the numerator of our answer. And I'm going to FOIL my numerator. 1 plus cosine of 2x plus another cosine of 2x plus cosine squared of 2x. And then in the bottom, that's just 4. At this point, I'm going to do some simplifying. I see I have like terms here in the middle that can be combined. I also have this 10 and 4 on the outside that can be simplified. So now that's 5 over 2. And 1 plus 2 cosine of 2x plus cosine squared 2x. So we're much better than we were because we're down from cosine to the fourth, cosine squared, but we still need to deal with that cosine squared. Now it's up to you. You can either distribute the 5 and then address the cosine squared, or you can do the cosine squared first. I think I'm going to distribute 5 plus 10 cosine of 2x plus 5 cosine squared 2x all over 2. So we see that we still have cosine squared, and we're trying to get down to just a power of 1, so we'll have to do our power reducing a second time. I'm going to rewrite everything that stays the same. And now we'll plug in our formula. That's 1 plus cosine of, our formula, remember, we're going from theta to 2 theta, so that means we're going from 2x to 4x here, over 2, and then all that's still over 2. I'm going to again distribute the 5. Five plus 10 cosine of 2x plus 5 plus 5 cosine of 4x. And just this part is over 2, but then all of this is also over 2. And now we want to simplify this complex fraction, multiplying by 2 everywhere. Ten plus 20 cosine of 2x plus 5 plus 5 cosine of 4x all over 4, and the very last thing we can do is combine these constants here. It's going to give us a final answer. 15 plus 20 cosine of 2x plus 5 cosine of 4x all over 4. Let's try another one. We want to rewrite 8 sine squared x cosine squared x as powers of just 1. So we're going to do a power reducing for sine squared. We're going to do a power reducing for cosine squared as well. 8 out in front. Do my sine squared here in green. So back up to our formula. Sine squared theta is 1 minus cosine of 2 theta over 2. Then I'll substitute my cosine squared in blue. And we've already used that a couple times. 1 plus cosine of 2x all over 2. And we want to simplify. So this 8, it's over 1. So we can simplify the 8 with both of these 2's. Right, that's 4 on the bottom. So if we simplify that 8 with the 4, we end up with a 2 out in front. So this is 2, and then we have our 2 numerators. And next we want to multiply this out. I'm going to leave my 2 out in front. I'm going to do my FOIL first. 1 plus cosine of 2x minus cosine of 2x minus cosine squared 2x. Combining like terms, we see our middles fall out. This is 2 times 1 minus cosine squared 2x. I'm going to distribute my 2. 2 minus 2 cosine squared of 2x. And here I have cosine squared again. So we'll plug in our power reducing formula a second time. Notice that we're starting with an argument of 2x. So when we plug it in and get 2 theta, we're actually going to have 4x in our argument. So this is going to be 2 minus 2 times 1 plus cosine of 4x over 2. We'll simplify these two 2's. They're going to cancel out, leaving us with 2 minus the quantity 1 plus cosine of 4x. It's going to turn minus when we distribute our negative. 2 minus 1 minus cosine of 4x gives us a final answer of 1 minus cosine of 4x. I know it doesn't seem like we got very far, but where these formulas are really beneficial are to us in the future when we're trying to solve trigonometric equations, verify trigonometric identities, do calculus things, integrate and differentiate with trigonometric functions.